All right, guys. So this is the video where I'm gonna go over problems, some, not all of them, of fluids, since most of the questions in the exams are conceptual. But it's always a good idea that you understand how to do some of these questions, like for example, question 1, where you have the pressure and the area, right? So, or sorry. Yeah, they want you to find the pressure, which is force divided by area. The force is 800, the area is 2 meters squared. So 800 over 2 meters squared is 400 Newton per meter squared, which we know is 400 pascals. All right? That is an example, all right, of how to do this. If they give the pressure and the area, the force is pressure times area. So questions 1, 2, and 3 are kind of the same. Let's take a look at buoyancy though. Okay, so let's go and let's take a look at question 7. I want to do a variety of different questions. So look at question 7. A block of wood with that mass, 3.5 kilograms, is floating in water. Calculate the buoyant force. All right. So if it's floating, if the body is floating, then the weight, if it has some mass, the weight of the body is equal to the buoyant force. All right? That's the Archimedes principle. The weight of the displaced liquid is equal to the buoyant force. Now, in this case, they don't tell you, but if it's floating, in that case, we assume that the weight, because it's in equilibrium, is equal to the buoyant force. So the buoyant force, I think I'm still showing the screen, right? The buoyant force is the weight, which is the mass was there 3.5 kilograms. Multiplied by 9.8. Right? So if you use a calculator, $34.3 newtons. There. Okay. Now, number 8. Let's share number 8. It's kind of the same idea. A floating object now is telling you it displaces a volume of water. Calculate, so that's the Archimedes principle, right? Again, just like the one I did, but now we know that the buoyant force by definition is equal to the weight of the displaced liquid. Now it's water and they give you the volume. So if you have the volume of water displaced, you can find the mass and therefore the weight. Right? Let's write some equations on the board for number 8. For number 8, the density of water, rho is the symbol for density, is equal to mass over volume. So we know that the volume displaced is of 0.6 meter cube. The density of water in kilograms per meter cube is equal to 1,000. So the mass is density times volume. 600 kilograms. So it's quite a lot, right? 600 kilograms is quite a lot. It's 10 times the mass of an average person. The weight, which is the buoyant force, right, is the mass times gravity. So 5,880 newtons. So quite a lot. But that's basically, right? That's how you do it. It's nothing out of the extraordinary. Buoyancy, pressure, density. Okay, now let's do a Pascal principle. Let's do number 9. Look at number 9 here. A pipe of cross-sectional area 80 centimeters square has a constriction where the area is reduced to 20 and the velocity of the, okay, so that's the continuity equation. It's still Pascal principle, right? If you have a system where the pressure is constant, right? Where you have two pipes, the area times the velocity on one side is equal to the area times the velocity. So the continuity equation basically, A1 V1 equals to A2 V2. So you're reading there, one has an area of 80 and it reduces to 20. If the velocity in the large is 0.3, what's the velocity in the other region? So 80 centimeters squared multiplied by V1. V1 in there is 0.3. I'm leaving it there so you guys can read it. Equals to 20 centimeters squared times V2. There. Centimeter squared, centimeter squared. So you divide by 20 on both sides. 4 times 0.3, 1.2 meters per second is the velocity on the constricted, on the second region, on the other region. So that's Pascal, that's using a Pascal's principle. All right. So those are the problems. Then you have a few questions here in regards to pressure, volume, and of course, in regards to the Archimedes principle, right? So let's take a look. Trying to, where do I share this? Here. For example, 11, Archimedes' principle states that an object immersed in a fluid is buoyed up by a force equal. Yeah, that's what we just did, right? So the answer here, right? The weight of the object is equal to the buoyant force. That's why an object floats. This is something that you guys should know from real life. If you add air to a tire, what happens with the pressure reading of your tire? It increases. You are adding more molecules of air, so the pressure will increase. It's kind of PV equals to nRT. The volume remains constant, the pressure has to go up, right? So that's basically what you have to do. All right. Now let me see if there are more questions in here. So I know there are a few that we can go over. Yeah, here it is. A child is drinking a liquid with a straw. Okay, that's another typical example. That's a pressure question, right? When you use a straw, you are reducing, and then the liquid is pushed up by atmospheric pressure on the surface. So that's the answer here. The hot air balloon will be Boyle's law, right? PV, pressure times volume, is constant. So a hot air balloon derives its lift from the property of fluids as Boyle's law. All right. So that's not bad, right? Constantly, Pascal principle states that an increase of pressure on an enclosed range transmitted constantly throughout the liquid. That's what we can use the Pascal principle. And then number 16, that's another, right? A hydraulic jug is used to lift a load of 4,000 newtons. That's basically 4 tons. No, sorry, my bad. 4 tons is 4,000 kilograms. So it's a bit less, it's less than that. The load bearing cylinder has a radius of 4 centimeters, and the piston has, so basically, right, if you press the piston, what force do you exert on the piston? So let's do that. All right, let's do that. I want to start writing on the board. So F1 over A1 equals to F2 over A2. That's basically what you need to do in question 16 in the practice. So F1 is 4,000 newtons. Yeah, newtons. And the area, so if it's a piston and they give you the radius, you can say pi times, let's stay with 4 squared. Because you know at the end of the day, the units are gonna cancel. What should be the force in the radius of 1? There. Look. Oh yeah, you were looking at it. So pi centimeter square, right? Here it will cancel. So 1 square is just 1. It will be 4,000 divided by 16. Okay, 4,000 divided by 16, which will be about 250 newtons. Right? Divided by 4 is 1,000. Divided by another 4 is 250. So way less on the other piston. 250 newtons is about 25 kilograms, which is the mass of a child, give or take, right? So that is kind of what I wanted to share in this video. It's not a lot. It will be a complement to the other video where I go over fluids, static fluids, Pascal principle. And again, I know that most of the exams are conceptual, but some of you are interested in the problems, how to solve some of the problems. So there you have it, all right? Please feel free to contact me if you have any questions, but so far I'm recording this at the beginning of October. So I think most of you are following the videos and the examples very, very well. Okay. So I'll see you guys. I'm gonna now record a video for heat, temperature and heat. All right. So see you guys then. Bye bye.